Has this ever happened to you? You want to go on a trip, let's say Bandung, Surabaya. You drive on the road and think, yes, I get enough fuel, but then run out of fuel on the side of the road. So how do you know how much fuel do you need? This is the topic of our project. Our project is a vehicle trip simulation that simulates refueling decision making based on vehicle fuel economy, trip distance, and current fuel volume before trip, while also taking into account the price per liter of different fuel types for fuel price calculation.
So in this project we made a database that is used to calculate the distance of total trip and an amount of fuel needed. Also the total amount of fuel that must be paid in the entire trip. What's the objective of our project? The objective of our project itself is to determine the fuel consumption and of the entire trip, factor in trip length and traffic, average vehicle speed, and average fuel economy of vehicle. The second objective of this project is to determine the amount of money needed to pay for trip for fuel value.
Now let's get into the actual code of our project. Starting off with the imported modules that were used in this project, the only module that we used was the math module. This module is useful for a variety of mathematical functions, but specifically in our project, we are using it to round up numbers, specifically with the math.ceiling function. This function is used to round up any float values. So for example, let's include 3.1 as our float value that we want to round up. With the math.ceiling function, this will always round it up to its nearest integer. So for example, if we only use the round function, this would result in a value of 3. But using the math.ceiling function, this will result in a value of 4. This is useful in our calculations for the amount of fuel stops that we need, because if you round down the float value, then it wouldn't be logical, since you cannot make too little fuel stops for your journey, since it will result in you running out of fuel before the total trip distance has been achieved. Next up, we're moving to our distance calculation. The first part of our distance calculations is the actual data array for the distances from Bandung to various different cities in Java. Represented by the Bandung_distances variable, this variable represents the data list of the distances from Bandung to various cities in Java. For example, the city of Jakarta from Bandung has a distance of 154. This is only using toll roads with the data for the distances taken from Google Maps. So Jalan Raya and other roads are not included in this dataset. However, the array itself won't have much use by itself. This is where the following code comes into use. Using this program highlighted, this loops through the entire data array for the inputted data for the following calculations. Starting off with destination_city, this variable represents the destination city that the vehicle will travel to from the origin city of Bandung. So the program will ask the user to input the desired city from Bandung. The city_found variable will equal to false initially. This is to check if it has actually found the city that is in the array itself. So following that, we use this program to identify if the city is available within the actual data array. So for city_tuple in Bandung distances, it will run city_name, which will be the city_tuple of 0 in the array. This means that it will take the first piece of data in the array itself. So for example, if you enter a city name of Jakarta, that will be the assigned variable. So for example, if you enter the data Jakarta, then that will be assigned as the meaning of the variable city underscore tuple. Then we have distance underscore value, which represents the distance value of the city from Bandung using city underscore tuple 1. This takes the second set of information from the array. So if you input Jakarta as the city name, it will automatically assign the distance value according to the number in the array. So in this case, 154. Then we use this if function to check if the city name is actually in the data array itself. If the city is found, then the city underscore found variable will be set to true. Then, if city underscore found, this will print the following text, where the distance to the assigned destination city will be trip distance in kilometers. This is to print out the distance of the destination city itself. Although if the city inputted was not found in the data array itself, it will be using this else function. So if city underscore found is false, still false, then the user will be asked to input the distances manually with the following program. So for example, if we input a valid city, for example, Jakarta, let's try testing the actual distance calculations. Let's try Jakarta. Inputting Jakarta yields a valid result, since the program loops throughout the entire distance array, the distance data array. It loops through the entire array to find the inputted data. And if the inputted data is valid, in this case, available in the data array, it will then provide us with the provided data for its distance. So inputting Jakarta results in a distance to Jakarta of 154 kilometers. However, if we input an invalid data, for example, Mumbai is not available in the actual array itself. The program loops throughout the entire data array for the term Mumbai. And if it doesn't call back Mumbai in the data, the program will then print the inputted data is not in the dictionary and will ask the user to enter the distance manually as kilometers as its unit. So let's say that the distance to the city from Bandung is, let's say, 1,000 kilometers. However, if the inputted data for the city is not found in the data and the user does not input a valid piece of information, for example, they say 200, written out in words instead of as a float value, the program will say that it is invalid and ask the user to input a valid distance. So let's write down 200. Now the program considers it as valid.
So now I will explain the rest of our code after the distance calculations. So first we need to count how much fuel are we going to consume. For that we divide the trip distance with the vehicle fuel consumption, which the user will have to input the average fuel consumption that their vehicle does. After that we make the refuel decision maker, which is, first of all, they need to input how much fuel they currently have in their fuel tank. After that, we count if the fuel we need for the trip is more than the current fuel, they need to refuel. Otherwise, it doesn't have to. And then fuel price calculations. First, we need to know what type of fuel that they use. in here we have our database, which is Pertalite, Pertamax, Pertamax Turbo, Solar, Xlite, Pertamina Dex. If there's any other fuel tank that it's not here, it will be they will have to input the price per liter manually. Fuel addition, and then we calculate how much fuel they need to add by minusing the fuel consumed for the trip and the current amount of fuel in the tank. Next, the user will have to put in how much the full tank of their vehicle can carry. Then we just calculate the price of fuel addition times price per liter. We'll print out the total cost and how much fuel they need additionally. And then in here we have the range calculations, so how much the car can go with a full tank of fuel and how much the car can go with its current tank of fuel. And then from there we will decide how many times the car will need to refuel. Now if I run the program, I'm going to put, let's say, Surabaya. I will put my average fuel consumption is at 12 liters. Current amount of fuel is at 26. It will say the vehicle needs to refuel. Type of fuel use, I will say Pertamax Turbo. And maximum fuel capacity, I will say 40 to 43. And then now it will detail how much fuel I need additionally, how much will that cost to refuel, my total distance on the fuel tank, my total range on the full tank, how far the range is with my current amount of fuel, and then how many refueling stops needed. So that is the overview of our code.
So good evening everyone, let me introduce myself. My name is Rafi Fazal Hakim and my student ID is 196-25191. So here I'm gonna explain about the topic of our project. So basically the topic of our project is a vehicle trip simulation that stimulates refueling decision making based on vehicle fuel economy, trip distance, and current fuel volume before trip, while also taking into account the price per liter of different fuel types for fuel price calculation. So in this project, we made a database that is used to calculate the distance of the total trip and the amount of fuel needed. Also the price fuel that must be paid in the entire trip. And we may have the next question. So what's the next question is, what's the objective of the project? The objective of our project basically to determine or find out the fuel consumption of the entire trip. So factoring trip length and traffic, average vehicle speeds, and also the average fuel economy of the vehicle. And the second one is objective. And the second objective is to find out or determine the amount of money needed to pay for the trip fuel volume. Okay, so that's from me. Thank you very much.